Alright, hi, hello everyone. Welcome back to my channel. It's me, David, aka The Blue. Today we got a new setup on the iPad so that you can actually see my writing a whole lot better. Anyways, on this video we're going to be trying to solve the integral of x minus 6 over x squared plus 6x plus 10. This is a problem I had in my most recent formative, if I remember correctly. And I actually didn't finish solving this because I was kind of confused. I have never done a problem like this before. I know it's based on different things that I did before, but it was those two combined. So I didn't actually finish solving this when I had it. So let's begin. I'm gonna zoom in first. So, uh, sorry. We had x minus 6 over x squared plus 6 plus 10. We actually can't factor that because if we try to, there's no number here, B or A, that would add up to like 10 and would what's called a equal to 6x, like at the bottom. I forgot how that method went because I haven't used it in a while. I'll normally just use the guess and check. So instead we're gonna complete the square. So let me just do that. X squared plus 6x plus 9 plus 10 minus 9. And remember, to complete the square, you take the b value and ax squared plus bx plus c. You take the, let me actually change this so that you can see it better. You take the b value divided by 2 and square it. So 6 divided by 2 and square that is going to equal to 9. And that's where this 9 comes from. Anyways, let me just get rid of this. So now that we have a square, we can move on to x minus 6, x squared, actually no wait, not x squared, x plus 3 squared plus 1, because 10 minus 9 is 1, and this is just x plus 3, that's a horrible 3, what in the world, sorry, x plus 3 squared. Anyways, so what do we do here after this? Because this is still not possible to solve with how we're doing it right now. So we're actually gonna have to separate this so that up here we have x minus 3. So we're gonna make this x minus 3 f x plus 3 squared plus 1, but we can't just get rid of 3, the number 3 from here. So we have to do plus negative, oh wait, sorry, x plus 3. We have to change that to x plus 3 plus negative 9 x plus 3 squared plus 1, because put those together we get x minus 6 again, dx. And now that we have this, we can actually begin solving. So actually first let's separate them into two integrals. So let me just rewrite this. Dx plus the integral of, there we go. Let's solve this first one, shall we? Ru is going to be the bottom function, so x plus 3 squared plus 1. Our du is going to be 2x plus 6. 1/2 over du is going to be x plus 3, making this 1 over u times du. Well, actually dx, sorry. I usually don't write this part, but du is just, has dx in there too. Anyways, and now we can turn this into sorry, I forgot 1/2 out there. 1/2 ln of u, which is, I'm just gonna write out here fully as x plus 3 squared plus 1. There we go. But that's only one part of our equation. Now let's take the integral of negative 9 x plus 3 squared plus 1 dx. And see, this is where I had a little bit of a problem, because we know that when it comes to problems like these, u squared plus a squared, I remember, if I remember correctly, this is 1 over a arc tan u over a plus c. But we don't have 1 over that. We have negative 9. And so somebody in the comments correct me if this is a valid rule or not. But I'm just going to take negative 9 outside. I'll do 1 over x plus 3 squared plus 1. This doesn't seem correct to me. So if anything happens, I'm just going to go back and try and take the derivative of my final answer to see if I'm correct. But anyways, after this, now we can use this equation over here. So u is equal to x plus 3 and a is equal to 1. So this is just going to be negative 9 times 1 over 1 tan x plus 3 over 1 plus c. So this is just going to be negative 9 tan negative 1 x plus 3. Sorry, actually, just I don't need to write over 1. X plus 3 plus c. So now let's combine both of our answers that we got. This is our let me write this down here. We got 1/2 ln of x plus 3 squared plus 1 minus 9 arctan x plus 3 plus c. This should be our answer. Now how do we know that this is correct? I'm going to take the derivative of that answer. So right here, d over dx of 1/2 ln of x plus 3, another horrible 3, I apologize, squared plus 1 minus 9 arctan x plus 3 plus c. Okay, so let's take the derivative of the first one. This is just going to be 1/2 over x plus 3 squared plus 1. Right, am I right? Am I doing this right? Oh, yeah, sorry, I just forgot to do a chain rule. Okay. Times 2x plus 6. And then I'm just going to do that differently later on here. Sorry. At a different time is what I meant. So this is just going to be 1 over 2. Sorry. This is just going to be not 1 over 2. The 2x plus 6 over 2 times x plus 3 squared plus 1. We can simplify that into x plus 3, x plus 3 squared plus 1. I'm pretty sure. Don't know if it's really valid, but I hope so. I hope it is. Hopefully. Anyways, over here, we're gonna now take the derivative of this, which I'm gonna separate to negative 9 times tan negative 1 x plus 3 plus c. I'm gonna do the product rule, so this is gonna be 0 times tan negative 1 x plus 3, and I'm just gonna ignore c because either way it's gonna be 0. Anyways, so this is 0, and now product rule is gonna be plus negative 9 times what did we say was our formula? 1 over u squared plus a squared. So it's gonna be 1 over x plus 3 squared plus 1 squared, which is just 1. So this is gonna be plus negative 9 x plus 3 squared. Let me fix that 3. That's a horrible 3. That's fine. Plus 3 squared plus 1. And then we add those together. It's going to be x minus 6 x plus 3 squared plus 1. Now, I don't know if I'm completely correct on this. Do not take my word. This is the way I came up with after thinking hard. I actually wasn't taught how to do this, so hopefully I'm correct. But anyways, if I am correct, this is how you solve this equation. Thanks for watching, guys. I hope you guys enjoyed. I'll see you guys next time. Goodbye.